A thunderstorm can turn ordinary water droplets into falling balls of ice, and sometimes those ice balls become big enough to smash roofs, cars, and crops. Hail begins inside a deep cumulonimbus cloud, where warm, moist air is forced upward very quickly. As that air rises, it cools, condenses, and builds the towering storm cloud we see from the ground. High in the cloud, temperatures fall below 0 degrees, but tiny water droplets do not always freeze straight away. They can become supercooled, meaning they are still liquid even though the air around them is below freezing. The moment those droplets hit a small piece of ice, a frozen raindrop, or grapple, they freeze onto it. That first little lump is the hailstone embryo. From there, the storm works like a giant ice-making machine. Powerful updrafts lift the embryo through freezing air, while turbulent winds push it sideways and down again through wetter parts of the cloud. Each time it collides with supercooled droplets, another skin of ice is added. Hailstones do not usually bounce up and down like a perfect yo-yo. More often, they follow slow looping paths through different parts of the storm. In very cold, drier air, droplets freeze instantly and trap tiny bubbles, making cloudy white ice. In slightly warmer, wetter air, water spreads over the stone before freezing, making clearer, harder ice. That is why a sliced hailstone can look like a tree trunk, with rings that tell the story of its trip through the cloud. The size of the hail depends mostly on the strength of the updraft. A weak updraft may only hold tiny ice pellets, which often melt before reaching the ground. Stronger updrafts can hold pea-sized or walnut-sized hail for longer. In a violent supercell thunderstorm, rotating updrafts called mesocyclones can keep large hail suspended for much longer, allowing stones to grow to golf ball, tennis ball, or even grapefruit size. Research shows giant hail may need updrafts around 257 to 290 kilometers per hour to stay aloft against gravity. Eventually, every hailstone reaches a limit. Once it becomes too heavy for the rising air, or it moves out of the updraft, gravity wins. The stone falls through the warmer air below the freezing level. Small hail may melt into heavy rain, but larger stones can survive the trip and hit the ground at dangerous speeds. Hail over 100 millimeters across can fall faster than 140 kilometers per hour, causing catastrophic damage and posing a serious risk to life. In Australia, severe hail is most common in spring and summer, especially along the east coast. Southeast Queensland and northern New South Wales are sometimes called Hailstorm Alley, where warm Pacific moisture meets cooler, drier air aloft near the Great Dividing Range. The 1999 Sydney hailstorm showed what these storms can do, with stones up to 9 by 11 centimeters and enormous damage costs. Forecasters watch for hail using radar. Ice reflects radar energy strongly, and modern dual polarization radar can help separate tumbling hail from flattened raindrops. On the ground, warning signs include a dark greenish sky, a sudden temperature drop, intense thunder, and a roaring sound from the approaching hail core. If a severe thunderstorm warning is issued, move cars under cover if it is safe, stay indoors, keep away from windows, and wait until the storm has fully passed. Hail is spectacular science, but it is also a serious hazard.